MS Ramaiah University of Applied Sciences.
Hi students, let us discuss the experiment on operational amplifier application as comparator and Schmitt trigger. The aim of the experiment is to construct and test the performance of a comparator using IC mu A741, to construct and test the performance of a Schmitt trigger using IC mu A741 for given values. The design formulas and calculations for choosing the components for the experiment is shown here. The upper and lower threshold point is decided by the experimenter. Based on these points, the circuit should be designed. Here, we consider case 1 for the examination. The figure shows the circuit diagram of comparator op-amp and the output waveform. The output of comparator compares the input signal with reference signal. The waveforms are plotted in the figure. The input for the circuit is given to any terminal, either the inverting terminal or non-inverting terminal. Based on the input given at the input terminal, the output will appear. Let us start the circuit connection based on the circuit diagram. The figure shows the circuit diagram of Schmitt trigger op-amp and the output waveform. The output of Schmitt trigger op-amp is a square waveform when the input given is a sinusoidal wave. The waveforms are plotted in the figure. The input for the circuit is given to any terminal, either the inverting terminal or non-inverting terminal. Based on the input given at the input terminal, the output will appear. The other terminal is used as a feedback with divider circuit. Let us start the circuit connection based on the circuit diagram. The result of comparator and Schmitt trigger op-amp is noted here in terms of volts.
Hi students, today I am going to do the experiment of operational amplifier applications for comparator and Schmitt trigger. The aim of the experiment is using mu A741 IC, operational amplifier IC, that can able to generate the waveforms, a compared waveforms and the waveforms for the Schmitt trigger. So now I am going to do the first experiment is the comparator. For the comparator, we have to compare one AC signal with the DC signal. The output that will be generated based upon the comparison by using mu A741, that is called as a comparator. To do the comparator experiment, we need the components signal generator. So this is the signal generator. This is the main power button to switch on the signal generator, and this is the on and off switch to exhibit the waveforms to the circuit board, and this is the monitor to display the waveform, and this is the sine wave, square wave, ramp wave, pulse wave, harp wave and noises that will be used to generate the signal to the input for the circuit. Two DC regulated dual power supplies. This is the DC regulated dual power supply. So this is the main switch on button to switch on this particular system. So we have two main parts here. One is this part and another one is this part. So I'm going to explain what is this part. So this is the voltage tuner and this is the current set tuner. So in the voltage tuner we have two main categories. One is coarse tune and one is a fine tune. If you want to tune your voltage to maximum level in maximum numbers, that will be used by coarse tuner. If you want to tune the voltage that in the minimum level, that will be choose with a fine tuner terminal. So if you want to set your current, that will be based upon the application, so you can set by using this current set terminal. So in our circuit we always keep this as a maximum current, and we have two main terminals. One is positive terminal and another is a negative terminal. So positive terminal is indicated by a red color and negative terminal that will be indicated by a black color. So this provides positive and negative voltage to the circuit, and the same operations what happens in this system that will be happen with this part also. And this is the ground connection. Normally we are used to this terminal in a very large applications. This is the display that will be used to display the values of voltage and current that will be generated to the system. Here we are using two DC regulated dual power supply. Why? Because we are using one DC dual power supply is to compare with a AC signal input. So this is also acts as an input. This input will be compared with the AC input, so that this dual power supply I am using for the input terminal, and this another one, that is a DC regulated dual power supply, that will be used to give the saturation voltage to the operational amplifier. Digital oscilloscope. This is the digital oscilloscope that will be used to measure the output. So in this device, this is the switch on button, so to turn on this system, and we have main two terminals. These are the one terminal and these are the another terminal, so we call this as a channel number 1 and the channel number 2 that will be used to see the output. Okay, these are all the tuners to adjust the amplitude and frequency of the signal. Two 1 kilo ohm resistors. These two are 1 kilo ohm resistors that will be used at the input terminals as from the circuit diagram. MUA 741 IC. This is IC MUA 741. This IC contains 8 pin. Okay, that will be start with the pin number of this notch. This is the notch that will be indicates the pin number 1. Okay, this is pin number 1, 2, 3, 4, 5, 6, 7, 8. This is the 8 pin IC MUA 741. Circuit board. So this is the circuit board or breadboard. This is used to connect our entire circuit. Okay, this is the series connection till this large gap, and again this is the series connection. So this is the series connection in x-axis, and this is the series connection in y-axis. Till this division that will be counted to 5, till that it is a series connection. After that this is one connection. Connecting wires. These are all the connecting wires to connect the circuit, and patch cards. This is the patch cards that will be used to connect the input and output devices to the circuit. Now let us start the circuit connection based upon the circuit diagram to exhibit the output waveform as a comparator. Now you take the breadboard MUA 741 IC. I am placing this IC to the circuit board. Now I placed this IC to the circuit board. So this is pin number 1, 2, 3, 4, 5, 6, 7, 8. So I am using 1 kilo ohm resistor to one terminal. So I am connecting this 1 kilo ohm resistor to the pin terminal 2 to somewhere in the circuit board. In the same way, I am taking the other 1 kilo ohm resistor and I connected to terminal 3 to somewhere in the circuit board. Next point. Okay. Now I am taking the connecting wires to connect the DC regulated power supply. The positive of the terminal that will be connected to pin number 7. This is 5, 6, 7. This is pin number 7. I am connecting this to pin number 7. Next, the negative terminal of the same will be connected to the ground. I made the ground somewhere here. Okay, this is ground. The same way I am connecting the positive of this terminal to the ground, and the negative will be connected to pin number 4. See here, 1, 2, 3, 4. This is pin number 4. I connected this to pin number 4. Now I am taking the patch card to connect the input from the signal generator. So this is the signal generator, output terminal 2 I am using. The positive of this is connected to any of these two terminals. So I am connecting to pin number 2. So this is the pin number 2 that will be connected to register. That register point, another point that will be connected to input of the positive signal. See here, it will be connected. The negative of the same that will be connected to ground. The next I am going to connect the positive of another wire L2 this is another input, it's a DC input. So I am connecting this to the other terminal that will be connected to 1 kilo ohm here. See here, I will connect the positive. And the negative of the terminal that will be connected to ground. So this is the ground. Now I am taking another patch card to connect the input, to show the input at the oscilloscope. I am using the port 1. So this is port 1, the positive, this is the positive end. I will connect it with the positive of the signal generator, and the negative end, so I need to connect it with the negative terminal of the signal generator. The other patch card I am using to see the output, connected to here. The positive of the wire that will be used to connect here, and another end that will be connected to pin number 6, because we want to see the output at pin number 6. So this is pin number 6 I am connecting here, and the negative terminal I made to ground. This is the ground part. See here, I am going to connect this to ground. See here, that will be connected to ground. Now the connection is complete as per the circuit diagram. Now you switch on the signal generator, and this is also one input device. Now it's a DC regulated dual power supply we are using as an input. You switch on that one, and this is DC regulated power supply. You need to switch on this. So we need to set these two terminals to 12 volt. So you set this to 12 volt. It's already 12 volt. Okay, you set this input to 1 volt as per the circuit diagram. You have to set this to 1 volt. Okay, so switch on the oscilloscope. Now you switch on the input. Okay, you will see frequency we need to set. The frequency we need to set. You click on frequency. This is the frequency setter. So I'm going to set this is 2 kilohertz. 2 kilohertz I need to set. So this is 2 kilohertz frequency I am setting. So you can set the amplitude. This is the amplitude setter. This is amplitude setter. So you click on amplitude, and you can type 8 volt peak to peak. You type 8 volt peak to peak. So now it is 8 volt peak to peak and 2 kilohertz input I am giving. I compare this with a 1 volt DC source. So 1 volt is the DC input I am giving at one terminal, and 2 kilohertz 8 volt peak to peak that will be given at other terminal. These two signals that will compare, because the operational amplifier will work as a differential amplifier. It will makes the difference. It will compare the two input signal. Then that is the output is generated. See here. See, if you compare 1 volt that will be, see, this is a comparator, this is the output. See here, this is the 1 volt reference throughout the straight line. So that will be compared with the sine signal. So the output will be in a square wave. Okay, this is called the comparator of the operational amplifier MUA 741. Now we can directly say our operational amplifier is working as the comparator. Now we complete the comparator experiment. So in the same way we are going to execute the Schmitt trigger. I'm going to execute the waveform for the Schmitt trigger. Now let us start the circuit connection based upon the circuit diagram. In the Schmitt trigger experiment, we are using only one DC regulated power supply, and one more component that will be added is 27 kilo ohm resistor we are adding. Now take the breadboard and MUA 741 IC. So I place this IC to the circuit board here, and so this is a 1 kilo ohm resistor. So I need to add this 1 kilo ohm resistor based upon circuit diagram. I need to connect. So 1 kilo ohm resistor that will be connected to terminal number 2 to somewhere in the circuit board. Terminal 2 it will be connected. It will be connected to somewhere in the circuit board. So I choose this point. I connected here. Another 1 kilo ohm resistor that will be connected to pin number 6 to the ground, or through the 27 kilo ohm resistor. See, you take 27 kilo ohm resistor. This is a 27 kilo ohm resistor. You connect this 27 kilo ohm resistor to the pin number 6. This is 5 and 6. This is pin number 6. Pin number 6 to somewhere in the circuit board. I connected this to somewhere in the circuit board. I choose this point, I connected here. Connected this. Next, I connected 1 kilo ohm resistor. The 1 kilo ohm resistor I connected to the resistance point to the ground. I made this point as a ground. I am connecting here. I am going to connect the pin number 3 to the resistor meeting point. So this is two resistors that will be meted right here. So I am going to connect. It acts as a feedback to the circuit. So I connected here to the pin number 3. See, this is pin number 3. I am connecting here. That will be connected, you see. Next, I am taking the connecting wires. So this positive wire, positive terminal connected to DC regulated power supply, positive to pin number 7. So this is 5, 6, 7. This is pin number 7. See here. So this is pin number 7. I am connecting this to pin number 7. And the negative will be connected to ground. See here, I made this as ground, this point as ground, so I connected somewhere here. And I am taking the negative of the other end is connected to pin number 4. So I am going to connect this to pin number 4. See here, this is pin number 4, last pin, so it will be connected. And the positive I need to connect it to ground. So this positive I need to connect to ground. So here it will be connected to ground. I made this as a ground, so I connecting here. Now I am taking the patch cords to connect the signal generator. Connect it to output port 2. So the positive end is connected with wire positive that will be connected to this input point. This is the input point resistor. I am connected. So and the negative will be connected to ground. So I made this point as a ground. I connecting here. Okay. Next, I am taking another to see the input on the oscilloscope. I connected this one probe to see the input. So I connected this probe to here. Over here to see the input. The positive end of this is connected to positive. So I am connecting like this. This will be connected to positive end. So negative end I am going to connect this to here. This is connected to negative end. Next, to see the output I am using another probe at the channel 2. So I connected another terminal and positive of that will be connected to pin number 6. So you see here that 5 and 6. So this is pin number 6. To see the output I am connecting here. See here, that will be connected to pin number 6. And the negative is connected to ground. I am taking another wire and to connect this to ground. I made this point as ground somewhere here. We have one lifted port here, so I'm connecting this wire to here. It makes the ground. See here, it will be connected to ground. They are all in series line, so it will be connected to ground. So this completes the circuit connection for the Schmitt trigger. Now switch on the signal generator, DC dual power supply and the oscilloscope. Set your DC regulated dual power supply to 12 volt. Saturation voltage we need to give for the operational amplifier, that is 12 volt. This also we need to set to 12 volt. Here we set the frequency to 2 kilohertz and amplitude to 8 volt peak to peak. Okay, switch on the input. Fine tune it to see the output. So based upon the design of UTP and LTP, we are getting the output at the oscilloscope. So our UTP will be -4 and LTP will be 2. So based upon that design, we are getting the output waveform. See here, we are connected to negative terminal, so that it will be an inverted output we are getting. This is the output that will be executed in a rectangular or squared wave. We are executed, there is the output. So this is the input, we are getting sinusoidal signal. So what happens now, the output that will be compared with the input reference voltage. Based upon that reference, it will generate the squared output, that is called as a Schmitt trigger. It's an improved version for the comparator. Now we can say the operational amplifier can able to execute or can able to exhibit the waveforms for the Schmitt trigger also. This completes the Schmitt trigger experiment.
At MSR UAS, we spark your imagination unlike any other.